Okay, next we are going to be working on the question 43 in chapter 4. The tensile strength of a paper product is related to the amount of hardwood in the pulp. 10 samples are produced in the pilot plant and the data obtained are shown in this table. So here, according to the statement, strength depends on the hardwood in the pulp. So we are in the first question it says with a linear regression model relating strength to percentage hardwood. So strength depends on the percentage hardwood, so strength is the y variable. Percentage hardwood can be considered as the x variable, and linear regression model will look like y is equal to beta 1 x plus beta 0 head, beta 1 head, okay, approximation. So we are going to do this on regression. So we are going to go to statistics, regression, and then regression again with regression model. We see the, okay, so before I do, actually I want to show you the data set. Okay, so the data set here, C24 and C23. C23 is showing the strength, C24 is showing the percentages. This is the y value, this is the x value you can consider. Okay, and now I'm gonna go to regression and with regression model. Okay, okay. Response variable is my strength. So I'm gonna just a second. Strength is gonna go in here, and continuous predictors are the sorry. This is the question 43. I'm sorry about that. 43. So this is the y variable, and then percentages. Okay. Let's check this out. Nothing here that we have to concerned about. Regression results, display results, expanded tables, basic simple tables, method, analysis of variance, model summary, coefficients, regression equation, fits and diagnostics. Okay, graphs, regular. We can have 4 in 1 if you want. Okay, click OK. Okay, here we see the okay, this is the one that we would need. Analysis of variance, results, model summary, coefficients. Okay, this is the regression equation that we are interested in. The regression model is gonna be this 143.82 plus 1.879 percentages. Okay, y is equal to beta 0 plus beta 1 head x value. Okay, so these are the residuals. We will use this later on. Okay, so this is the regression equation that we get. We have some more information here. The predictor and the constant. This is the constant value 144. Get the coefficients 144 and 188. this belongs to the x value. Okay, the standard error coefficients are given. Standard error coefficients with respect to the x variable is this, and the constant is this. T values and p values are here. Okay, so it says test the model in part A for significance of regression. So for the regression, we are going to test whether beta 1 is equal to 0 or not, because if beta 1 is equal to 0, then there is no relationship between y and x, right? So our alternative hypothesis is beta 1 is not 0. Hopefully we are going to get that. Okay, so we have the f test for it. f0 is equal to MSR over MSE. MSR, we can find it from here. So analysis of variance, MS of regression, mean squared regression, 1262.1, it's in here. Mean square error, okay, 4.9. If we take the ratio, we get f0. So we also need to find f alpha n1, so these degrees of freedom 1 and 8 here, okay, 1 and 8 in here, degrees of freedom. So we go to the F table and we find that this is 5.32. This is less than 260. We failed, we reject beta 1. So we have H1 alternative hypothesis is true, so that means the regression is significant, which means we can write y in terms of x as a linear combination. Okay, you can also check out the equation 4.97 in our book for this statement. Okay, another thing is we want to find the 95% confidence interval on the parameter beta 1. Okay. You can also see the f value here, 260. By hand, you can find it like that. And another thing that we are going to reject, null hypothesis, p is very small, alpha is bigger than that, so we are going to reject null hypothesis, so we accept H1. That's another way to say it. Okay. And then find a 95% confidence interval. Okay, beta 1 can be estimated by beta 1 head, but the interval is going to be written as beta 1 head minus t alpha over 2 and minus 2, standard error of beta 1 head. So what's the standard error for beta 1 head? We need to find it from our output. Standard error, so this is the, so standard error coefficients are in here. Standard error coefficients for x, which is beta 1, is 0.1165. Standard error coefficients for the constant is this, so we are going to use 0.1165 right here, 1165 right here, and then beta 1 lies in this interval. That's the end of the question.